The question is, an individual is endowed with an income of $142 and has a utility function that is u of x1 comma x2 is equal to x2 bracket x1 plus 1, where x2 and x1 are the two goods, where both the goods are positive, the quantities of both the goods. The unit price of good x1 is $2 and unit price of good x2 is $3. We need to find out the profit maximizing bundle. Okay, so basically what we are being told to find, if we have x1 on this side, x2 on vertical side, we are being told, given the budget line, okay, we want to reach to the highest possible indifference curve. Okay, so highest possible indifference curve will lie where indifference curve and budget lines are, tangent to each other. That means when the slope of the indifference curve is equal to the budget line. And what is the slope of budget line? At this point, slope of the budget line is simply price of good one, or let's write it here, where our MRS is equal to P1 upon P2. MRS means the slope of indifference curve. The ratio of the prices, that is P1 upon P2, is the slope of the budget line, where the indifference curve and budget line on tangent to each other. That will give us the utility maximizing bundle. We need to find out that very stuff. Okay, so what we are being given? We are being given the utility function u is equal to x2 times x1, if I multiply it here, plus x2. This is our utility function. Okay, we want to maximize this utility function. We are also being told that price of good one is equal to $2, price of good two is $3, income of the consumer is $142. If I construct the budget constraint, that will mean P1 times units of good 1 plus price of good 2 times units of good 2 should be exhausted on the income. Okay, so total income should get exhausted on these two goods given the prices of these two goods. Our question is then, or our problem is to maximize this utility subject to this budget constraint. Given this budget constraint, we want to maximize our utility. So we know that our first order condition for maximum requires that our MRS should be equal to the ratio of the prices P1 upon P2. This condition, what I am talking about, MRS is simply marginal utility of good x1 divided by marginal utility of good x2 should be equal to the ratio of the prices. MU1 means the partial derivative of utility function with respect to x1, and MUX2 means the partial derivative of utility function with respect to good 2 should be equal to the ratio of the prices. Okay, so du upon dx1 means to take the derivative of utility function with respect to x1. If I take the derivative with respect to x1, derivative of x1 will be 1, so we will be left with only x2. Since no x1 is involved in the second term, its derivative will be 0. Then we divide and take derivative with respect to x2 of the utility function. Derivative of x2 will be 1, so we will be left with x1 plus derivative of x2 here will be 1, and it should be equal to the ratio of the prices. P2 is 2, P1 is 2, P2 is 3. That implies 3 times x2 should be equal to, I am cross multiplying it here, 2 times x1 plus 1, which gives us x2 is equal to 2 upon 3 x1 plus 1. Now plug this value back into the budget constraint. And where is our budget constraint? I have not constructed the budget constraint. Let me construct it. Okay, so budget constraint is P1. So what is P1? P1 is 2, P2 is 3, so in place of this I can write 3. and income is 142. Okay, so हो गया हमारा budget constraint. So in place of x2 we write this expression, that means 2x1 plus 3, the value of x2 is 2 upon 3, x1 plus 1 should be equal to 142. That implies 3 and 3 gets cancelled. We get 2x1 plus, here we get 2x1 plus 2 ones are 2 should be equal to 142, which implies that is okay, 4x1 is equal to, transposing 2 it will get subtracted with 142, so we will be left with 140 only. That means x1 will be equal to 140 divided by 4. So this is 4 3s are 12, 13 14, 4 5s are 20. That means optimal quantity of good x1 will be 35. So we got x1 is equal to 35. To find the value of x2, simply plug x1 into this relationship here. Okay, that gives us x2 will be equal to 2 upon 3. X1 we got 35 plus 1, so we have x2 will be equal to 2 upon 3 times 36. 3 ones are 3 12s are, so 12 twos are, I hope I did the calculation right here. So this comes out to be 24. That means consumer should consume 24 units of good x2 and 35 units of good x1. The question is, a labor augmenting production function is y is equal to k to the power 0.33 times al raised power 0.67, where y is the output, k is the capital, l is the labor, and a is the state of technology. Sorry. Assume that the growth rate of L is 1.2% per annum, growth rate of K is 3% per annum, and growth rate of technology, which is denoted by A, is 1.5% per annum. Using growth accounting approach, the growth rate of output, which is Y, in percent per annum is, we need to find out the answer, round off to 2 decimal places. Okay, so first we will derive the growth accounting equation, and let us see what we are being given. First, we are being given a production function y is equal to k to the power 0.33. If I expand this, it will become a to the power 0.67 times l to the power 0.67. Okay, we will take log on both sides. That means log of y will be equal to, so log of k to the power 0.33 is simply 0.33 log of k. Simply if we have x to the power n, its log is simply n becomes coefficient, we have log of x. Okay, so in place of x we have k here, and in place of n we have 0.33 plus, okay, from the law of logarithm, I hope you know how do we, how does this plus came out to be. If we have, and let me write it here to explain it, if we have y is equal to x to the power n times y to the power w times s to the power any number, let us say b. Okay, then if we take log on both sides, log of y will be equal to log of this whole term, x to the power n times y to the power w times s to the power b. Okay, then this can be written as this log of x to the power n plus log of y to the power w plus log of s to the power b. From the law of logarithm, if we have log of x times y, it is simply equal to log of x plus log of y. I'm just using that very thing here. So that's why then log of x to the power n is simply n log x plus log of y to the power w is w becomes coefficient, so we have this stuff here, so b becomes coefficient log of s, this type and this. Okay, this thing is actually what I am writing here. So here 0.67 will become 0.67 becomes coefficient, we have log of a plus, okay, I have explained how this works out. Then we have 0.67 again log of L. Now taking differential on both sides, so derivative of y will be equal to 1 upon y times del y is equal to, we have 0.33 log of k is simply 1 upon k del k, plus we have 0.67 derivative of log a is 1 upon a del a, and let me rub this out, emission ज़रूरत व किहन, plus here again 0.67 derivative of log L is 1 upon L del L. I can write it in this fashion also, del y upon del y upon y is equal to 0.33 del k upon k plus 0.67 del a upon a plus 0.67 del L upon L. Now what exactly does this equation tell us? Del y upon y means the percentage growth rate of output. Del k upon k shows us the percentage growth rate of capital. Simply change in capital divided by original capital will give us the percentage, growth. Del a upon a, again it shows the percentage growth of state of technology, and del L upon L means that is change in capital divided by original capital. It gives us the percentage value. So this is percentage, value of labor. Okay. So del k upon k, let us see what we are being given. We are being told, let us denote G subscript k as growth rate of capital. What is the growth rate of capital given? Suppose that the growth rate of L is 1.2%, growth rate of K is 3%. So we have growth rate of capital is 3%. And what is growth rate of L? Growth rate of L is being given us as 1.2%, 1.2%. And growth rate of state of technology, let us denote it by G subscript A, it is being given us as 1.5%, 1.5%. We were supposed to find out the growth rate of output. Okay, so this denotes the growth rate of output is equal to, growth rate of output will be equal to 0.33. So del k upon k denotes the growth rate of capital. Growth rate of capital is 3%. So we multiply it by 3%, plus we have 0.67. Growth rate of state of technology is being given us as 1.5%. So we multiply it by 1.5%, plus we have 0.67 again. Growth rate of labor is being given us as 1.2%. 1.2%. That means growth rate of A will be equal to growth rate of output will be equal to, so 0.33 of 3%, it comes out to be 0.99%, plus 0.67 times 1.5, it comes out to be 1.005%, plus 0.67 times 1.2, it comes out to be 0.804%. Adding this up, it will come out to be 2.78%. That means growth rate of output will be equal to 2.78. So we will have here 2.78. Okay, I hope I made the calculation right. Consider the Keynesian cross model with the linear consumption function and zero tax, where government purchase is $100 and equilibrium income is $1,300. If government purchase increased to $125, the equilibrium income increases to $1,400. Using the given information, we need to find out the marginal propensity to consume. Okay. So what we are being given here, we are being given that initially, and let's write it here, initially government expenditure is equal to $100 and initial equilibrium income is $1,300. After government expenditure increases to 125, let us denote it by G dash. When it increases to $125, the equilibrium income is, let's denote by Y dash, is $114. We need to find out the MPC, that is marginal propensity to consume. Okay, we are being given a linear consumption function. Okay, also we are being given the linear consumption function, that is C is equal to A plus BY. Okay, and we have zero tax here. We need to find out the value of this B. So we have two things here. So using the growth growth identity, or we know that our Y should be equal to consumption plus investment is not being given, we are also only being given the government expenditure. This will be our initial equation. Now Y is equal to, so C is A plus BY plus what is initially the value of government expenditure, it is 100. So if I transpose this Y here, so that is Y minus BY is equal to A plus 100. That means if I take Y common, Y is equal to rather it will become Y times 1 minus B. B denotes the marginal propensity to consume, is equal to A plus 100, or our Y is equal to A divided by, A plus 100 divided by 1 minus MPC, which is denoted by B. So this is our initial equilibrium. So initially our equilibrium is being denoted by, that is our initial equilibrium. That means in place of Y we have 1300 is equal to A plus 100 divided by 1 minus B. Okay, simple thing. Initially government expenditure is 100, equilibrium level of income is 1300. After that, what happens, and let's write it here. We are being told that government expenditure has increased to $125, and let's denote it by, that means our new equilibrium will be equal to A will be constant, plus now new equilibrium, rather new government expenditure is 125 divided by 1 minus B. Okay, and it is being denoted by, or let's write it here first to make it sense. So we have G dash here. Okay, so this is our Y dash. That means Y dash is new equilibrium income is 1400 is equal to A plus government expenditure is 125 divided by 1 minus B. Let us say this is equation first, this is equation second. Dividing equation first by second, first we need to find out the value of A, because we have two unknowns here. So dividing it, we will get 1300 on RHS. on LHS divided by 1400 will be equal to, here we have A plus 100 divided by 1 minus B. When I divide this term, it will get multiplied and reciprocated. It will become 1 minus B divided by A plus 125. So these two get cancelled. That gives us 1300 times A is 1300, 1300 A plus, okay, I could have, let us cancel these two also. So 13, we will get 13A plus 13 into 125, it will come out to be 1625, should be equal to multiplying this with this. So 14 into A plus, we will get 1400, 1400. That gives us, transposing this 13A here, so it will get subtracted. So 14 minus 13A is A will be equal to, and transposing this 1400 here, it will get subtracted. 1625 minus 1400, it will come out to be 225. That means our A is equal to 225. That is our autonomous consumption. So we got the value of this. Now we need to find out the value of MPC. Simply what we need to do, simply plug the value of A is equal to 225 either in equation first or second. Okay, let's put the value of A in the second equation. So we have 1400 is equal to, A is 225 plus 100 divided by 1 minus B. So solving this, we have 1400 is equal to 225, so this becomes 325 divided by 1 minus B. Okay, so this is 1400, so it becomes 1400 minus 1400B is equal to 325. I hope I am making the calculation right. So it is 1400 is equal to, subtracting, we have 1400 to this we subtract 325. So dahne 5 to 5, 9 is the 7, 9 is the 7, 3 is 0. So we got 1075, 1075. So here we have 1400B is equal to this. That gives B will be equal to 1075 divided by 1400. Solving this, it will give us the value of, MPC. It will come out to be 0.75. That means we will get 0.75. The right answer should be 0.75. So we got the value of marginal propensity to consume. The question is, consider the Keynesian consumption function as C is equal to alpha plus beta y, where C is the aggregate consumption, y is the aggregate income, alpha is a constant which is greater than 0, and beta is the marginal propensity to consume, and beta lies between 0 and 1. Then average propensity to consume, that is APCs, the options are being given. We need to find out the correct option. So what we are being given, C is equal to alpha plus beta y. That means consumption depends upon the level of income. Beta is our marginal propensity to consume, how much we consume when income increases by 1 unit. That is being explained by this beta. Alpha denotes the autonomous consumption, that does not depend upon the level of income, whether income is 0 or 10, we have to consume something. Okay, the question tells us to find out the APC, that is average propensity to consume. It is simply equal to, APC is simply equal to total consumption divided by total income. Okay, so consumption is being given. It was a straightforward question. Alpha plus beta y, to this we divide by y, which gives us alpha upon y plus beta y upon y. So we will get alpha upon y plus beta. So this denotes our average propensity to consume. That is alpha upon y plus beta. That means this option should be correct. The question is, consider the following short-run cost function. C of q is equal to 10q cube minus 80q square plus 300q plus 50, where q denotes the output. At the minimum average variable cost, the value of marginal cost is we need to find out. Okay, so graphically what we are being told to find out, let us say this is the simplest graph. Here we have output on the horizontal axis, average variable cost and marginal cost on vertical axis. Let us draw the average variable cost function like this. Let us say this is average variable cost. Okay, we are being told to find the minimum average variable cost. Okay, average variable cost will be minimum where the slope of the average variable cost is 0. Let us say this is the point where the slope will be equal to 0. Corresponding to this point, we need to find out the marginal cost. Okay, so let us draw the marginal cost. Karo here marginal cost. Okay, that means the value of marginal cost at the minimum of average variable cost. Okay, let us see what we are being given. We are being given the cost function is C is equal to 10q cube minus 80q square plus 300q plus 50. This is our total cost function. Let us see what is here the variable cost and fixed cost. The terms where q is involved is our variable cost, that very cost which changes with the change in output level, and this constant which is 50 here, it will be fixed cost. Okay, this $50 of fixed cost has to be incurred by the firm whether production is 0, 10 or 100. This is a fixed cost. It does not depend upon the level of output. Okay, since no q is involved in this 50. So our average variable cost will be equal to variable cost divided by output. Okay, variable cost is this function, that is 10q cube minus 80q square plus 300q. To this we divide by q. So this will become, so our AVC will be equal to, so 10q cube divided by q, it comes out to be 10q square minus, here 1q will get cancelled, we will be left with 80q plus 300. This is our average variable cost. But we need to find out the minimum of average variable cost. Okay, minimum of AVC. What exactly is meant by this? That means the minimum point will be there where the slope is equal to 0. When slope is equal to 0 here, okay, that means the derivative, we take the derivative of average variable cost with respect to output and set it equal to 0. Okay, so that means DAVC divided by DQ. So this denotes the slope of average variable cost, and when we set it equal to 0, so the point where the slope is equal to 0 of average variable cost will give us the minimum point. Okay, which implies, so taking derivative of this function with respect to output, derivative of q square is 2q, so we will get 20 q minus derivative of q is 1 here, so we will be left with 80. Derivative of a constant is obviously 0, so we set it equal to 0. This denotes the derivative of average variable cost with respect to output, and we set it equal to 0 to get the minimum point of AVC. So this means 20 q is equal to 80, which implies q will be equal to 80 divided by 20 is equal to 4. So we got 4 units of output, where average variable cost is minimum. Okay, now we need to find out the marginal cost corresponding to this very level of output. What is marginal cost? Simply the derivative of cost function with respect to output. Okay, which implies, so this is our total cost function, its derivative of q will be equal to 3q square. So 3 into 10 is 30 q square minus derivative of q square is 2q, so 2 8s are 16, 160 q. Derivative of q in 300 q is 1, so we will be left with 300, and derivative of a constant is obviously 0. This is our marginal cost. Now we need to find out the marginal cost at q is equal to 4. So let us plug the value of q is equal to 4 in this marginal cost function. That is, we have 30 into 4 square minus 160 into 4 plus 300. So this is 30 into 16 minus 4 zeros are 0, 4 6 are 24, 4 1s are 4, 5 6 plus 300. So this becomes, we have 0, 3 6 are 18, 3 1s are 3, ताकि 4, 400 minus, sorry, 480 minus 640 plus 300. This comes out to be, so 780 minus 640. So this comes out to be 0 0 8 4 4 7 1. That means the marginal cost where average variable cost is minimum is equal to 140. Okay. A firm has two types of workers: skilled, whose salary is 40,000 rupees per worker, and unskilled, whose salary is 15,000 per worker. If total wage of the firm is 23,75,000 rupees of 100 workers, find the number of skilled workers. Okay, so we are being given the salary of, let us denote it by the salary S subscript C denotes the salary of skilled workers is being given us as 40,000. Salary of unskilled workers is being given us as 15,000. Okay, and we are being told total number of workers is equal to 100. That means skilled plus unskilled will be equal to 100. Okay, total wage bill is being given us. Let's denote it by simply, okay, to TW denotes the total wage here, 23,75,000. Okay, we need to find out the number of skilled workers. Okay, simple thing, total wage will be equal to, okay, or total cost of the firm will be equal to, a salary of skilled workers, which is 40,000. Okay, let me write it here, 40,000 times the number of skilled workers plus salary of unskilled workers, which is, you can say this is the price also, price of skilled workers per worker. Okay, 15,000 unskilled. Okay, total wage will be equal to salary of skilled workers times number of skilled workers plus salary of unskilled workers times the number of unskilled workers. Total wage is being given us as 2375,000. Okay, here we have this very equation. If we solve this for s, so s will be equal to, okay, s will be equal to 100, or let us solve it for u. Okay, if 100 plus s plus u is equal to 100, I can write it in this fashion: u will be equal to 100 minus s. Okay, now we have here 40,000 plus 15,000. In place of u we have 100 minus s. Okay, solving this will give us, so we have 2375,000 should be equal to, we have 40,000 plus, we have 1 5 1 2 3 4 5, 1 2 3 4 5. So this is 15 lakh minus 15,000 s. Okay, solving this relationship. Now if I, so here we have s, I forgot to write, here we have s. Okay, transposing this here, it will get subtracted. We have 2 3 7 5 8 2 3 minus 1 5 8 2 3 4 5 is equal to 40,000 s minus 15,000 s comes out to be 25,000 s. Okay, when we subtract 15 lakh from 2,75,000, we get, 875,000 will be equal to 8,75,000. It should be equal to 25,000 s. Solving for s, that is 25,000 s will be equal to 875,000. So s will be equal to, transposing this, it will get divided, 875,000 divided by 25,000. So 000 gets cancelled. So we will get here s will be equal to 25 ones are 25, 3s are 75. Okay, solving this, it will give us 35. That means number of skilled workers for this firm will be equal to 35. This, a 250 ml mango juice bottle has a price of $4 and exchange rate ratio is 0.02 per rupee. What would be the price of same bottle in rupees? Okay, so what we are being given, we are being given that we have a bottle of mango juice whose price is, $4. Okay, we need to calculate the price in Indian rupees given the exchange rate. And what is exchange rate? Exchange rate is, that means 1 rupee is equal to 0.02 dollar. Okay, so I can write it in this fashion, that is 0.02 dollar is equal to 1 rupee. Or we can do one thing here, using a unitary method, that implies $1 will be equal to, so we transpose this, it will get divided. That means we have 1 upon 0.02, which gives us, $1 is equal to 1 upon 0.02 comes out to be 1 upon, 2 upon 100. So this comes out to be 100 upon 2, which is equal to 50. Okay, so 1 upon 0.02 comes out to be 50. So $1 is equal to 50 rupees. The price of bottle is $4. That means 4 into $1 will be equal to, so we multiply this also with 4. So we have 4 into 50 rupees. That gives us, 4 5s are 200 rupees. Okay, that means the price of same bottle will be 200 rupees. Okay, so we have 200 here. The question is, if average tax rate increases with income, given the tax function t is equal to a plus ty, t denotes the tax rate, y is the income, what is the value of a? The options are, it must be 0. Second option is must any value, sorry, except 0. Third option is negative. Fourth option is it must be positive. Okay, so we have tax t is equal to a plus ty. What is ATR then? Average tax rate will be equal to t upon y. Okay, so this becomes a upon y plus t. That means ATR is equal to a upon y plus t. This is our average tax rate. Okay, now we need to maintain a positive relationship between income and average tax rate. That means our average tax rate should increase when income increases. We need to find out what must be the value of a here. Okay, so let me write it again here. We have ATR is equal to A upon Y plus T. Okay, we have to maintain this relationship. When income increases, average tax rate should also increase. Then what should be the value of A here? Okay, now if A is equal to 0, okay, if A is here 0, this whole term becomes 0, then average tax rate will remain constant. Okay, so it cannot be 0. Second option is any value except 0. By any value we mean positive or negative. Let us see first the positive value. Okay, if this condition should be satisfied, okay, if ATR should increase when income increases, okay, if this relation is to be maintained, and if we assume that the value of A is positive, then what happens if income increases here? If income increases, then average tax rate will decrease. Okay, so we will get a negative relationship here, so it cannot be positive. But what happens if this is negative? Okay, if A is negative and if income increases, then our average tax rate will also increase. Okay, so the correct option should be C part. Let me explain it with an example to make it more sense. Okay, let us take the tax function is T is equal to, let's take the positive value of A first. So let us say we have 40 plus 0.5 100. 0.5 denotes the 50% here. Okay, then what is the average tax rate? Average tax rate is simply tax upon the initial income. Initial income is 100, so it becomes 40 upon 100 plus, so here 100 and 100 will get cancelled. We will be left with 0.5. Remember, this 0.5 is 50%, so this is 40%, this is 50%, it comes out to be 90%. Now let us say when income increases to 200, what will be our tax function? So tax function will be 40 plus 0.5 times 200. Then average tax rate will be equal to 40 upon 200 plus 0.5. Okay, I am dividing this equation with initial income to get the average tax rate, and here it is 40 upon 200, it will come out to be negative, sorry, it will come out to be 20% plus 50%, it comes out to be 70%. Here you can see when income increases from 100 to 200, average tax revenue has decreased from 90% to 70%. But what happens if the first term is negative here? It is negative here. What will happen then? You can see when A is negative, so this is here negative 40% plus 50%, so negative 40% plus 50% comes out to be 10%. Here when income increases to 200, so we have negative 20% here. Okay, so negative 20% plus 50%, it comes out to be 30%. So if this relation is to be maintained, that if income increases and average tax revenue also increases, then the value of A should be negative. Okay, so the correct option should be this negative one. And here we have seen when income increases from 100 to 200, average tax revenue has increased from 10% to 30%. The question is, a duopoly faces the market inverse demand function as P is equal to 120 minus Q, where P is the unit price of good being sold by firms A and B, and Q is the total output. Firm A has a marginal cost of $20, which is exactly half of firm B's constant marginal cost. There is no fixed cost for both the firms. If there exists a Carnot Nash equilibrium, we need to find out the value of Q, that is total output in this market. Okay, uh, so this is our inverse demand function that is being given. Marginal cost of firm A, I am writing in place of A and B as 1 and 2 for the sake of simplicity. So marginal cost of firm 1 will be 20, which is being given us, and we are being told it is exactly half of the marginal cost of firm second, that is firm B. That means firm second will have twice the marginal cost of firm A, so MC2 will be equal to 40. Given this inverse demand function, Q denotes the total output. Okay, let us rewrite it. That is P will be equal to 120 minus, since Q is the total output, we can write it in this fashion: Q1, that is output of firm 1, plus Q2, output of firm 2. That means Q1 plus Q2 will add up to Q. Since we have two firms, so this is a duopoly model, and we have the Carnot problem here. To solve for Carnot Nash equilibrium, we need to find out the response functions of each firm, that is best response function of each firm. How do we find the best response function of each firm? Let us first calculate the best response function of firm 1, okay, which is firm A. So first we need to find out the total revenue of firm 1. Let's denote it by TR. That will be equal to P into Q1. So our P is this 120 minus Q1 minus Q2. To this we multiply Q1. So this becomes 120 Q1 minus Q1 square minus Q1 Q2. This is total revenue of firm 1, the function rather. What is marginal revenue? Marginal revenue of firm 1 will be the derivative of this total revenue function with respect to output, that is with respect to Q1, that is dTR1 with respect to Q1. We take derivative of this function partially with respect to Q1, so we will get 120 minus twice Q1 minus Q2. So this is our marginal revenue. Next we need to find out the marginal cost that is being given us. Now equilibrium requires our marginal revenue 1 should be equal to marginal cost 1. That means marginal revenue of firm 1 should be equal to marginal cost of firm 1. Marginal revenue we calculated, it is 120 minus twice Q1 minus Q2. It should be equal to marginal cost, which is being given us as 20. So this becomes 100. If I transpose it here, 100, and let's transpose it here. So we will get Q2 is equal to twice Q1. Solving for Q1, Q1 will be equal to 50 minus 1 half of Q2. This is the best response function of firm 1. By best response for by best response function, what we mean, it is the best response of firm 1 in terms of output level decided by firm 2. How firm 1 reacts in terms of output? When firm 2 has set the output as Q2, or it simply tells us optimal quantity firm 1 should produce given firm 2 produces Q2. Okay, symmetrically we need to find out the BR2, that means best response function of firm 2. Again same method. First we need to find out the total revenue of firm 2 will be equal to P into Q2. So P inverse demand function is 120 minus Q1 minus Q2. To this we multiply Q2. That gives us 120 Q2 minus Q1 Q2 minus Q2 square. This is our total revenue function of firm 2. Now what will be the marginal revenue? Marginal revenue of firm 2 will be the derivative of, that is partial derivative of total revenue function of firm 2 with respect to Q2. So we have here 120 minus derivative of Q2 is 1, Q1 minus twice Q2. Again at equilibrium, marginal revenue of firm 2 should be equal to marginal cost of firm 2. So this implies 120 minus Q1 minus 2Q2 should be equal to, the marginal cost of firm 2 is 40. So 120 minus 40 is 80 minus Q1 is equal to twice Q2, transposing this here, or Q2 will be equal to, so it is 40 minus 1 upon 2 Q1. I hope I am doing it correctly. So mistakes happen. I apologize for that very stuff. It is, inevitable. So this is the best response function of firm 2. Simply the optimal quantity that firm 2 should produce given firm 1 has produced Q1 quantity. This is called the BRF, or reaction function of firm 2. Now Q1 is equal to this, Q2 is equal to this. Simply plug the value of Q2 is equal to this into this function, or the value of Q1 here, it is one and the same thing, to find the Q1 and Q2. So our Q1 will be equal to, we have 50 minus 1 half of, what is Q2? It is 40 minus 1 upon 2 Q1. Solving. So we have Q1 will be equal to 50 minus, it is 20, minus minus is plus 1 upon 4 Q1, which implies, if I transpose it here, it is Q1 minus Q1 divided by 4, okay, will be equal to 30, which implies, so is it 30? Yes. Okay. So this becomes 4Q1. So this is 3 upon 4. 3 upon 4 Q1 is equal to 30, which implies Q1 will be equal to 30 into, transposing it, it will be 4 upon 3. 3 ones are 3 tens are. So 10 fours are 40. Q1 will be equal to 40. If Q1 is equal to 40, what will be Q2? Q2 will be equal to, so since Q2 is equal to this stuff, so Q2 is equal to 40 minus 1 upon 2. Q1 we got is 40, which comes out to be 40 minus 20, which comes out to be, so 40 minus, am I doing the calculation right or not? So 40 minus 3 ones are 10 fours are 40. Okay, so Q1 is 40. This is our reaction function. So 40 minus 20, it comes out to be 20. So firm 1 should produce 40 units, firm 2 should produce 20 units. That means Q will be equal to Q1 plus Q2. Total output will be equal to, we have 40 plus 20. That comes out to be 60. The correct answer should be 60. The question is, suppose from the estimation of linear regression model, that is yi is equal to beta naught plus beta 1 xi plus ei, the residual sum of squares and total sum of squares are obtained as 44 and 80 respectively. The value of coefficient of determination is, we need to find out very thing. What we are being given? We are being given a linear regression model is yi is equal to beta naught plus beta 1 xi plus ei. Okay, let us see here. This yi is the dependent variable and this xi denotes the independent variable. Okay, what we are being given, we are being given the residual sum of squares is equal to 44, total sum of squares is equal to 80. We need to find out the value of r square, that is coefficient of determination. By coefficient of determination, what we mean, it's that is coefficient of determination is the proportion of variation in the dependent variable that is explained by the variation in the independent variable. Okay, how much variation in percentage of dependent variable is being explained by this independent variable, that we call the what we call the coefficient of determination, and it is equal to simply 1 minus RSS, that means residual sum of squares divided by total sum of squares. Okay, so we have 1 minus RSS is being given us as 44 divided by 80, which gives us 1 minus 44 divided by 80 comes out to be 0.55. That gives us 0.45. That means our r square will be equal to 0.45. And how do we interpret it? When coefficient of determination is 0.45, it says us that 45% of the variation in dependent variable, which is y I, is explained by the variation in independent variable. Okay, the question is, a monopolist is facing the demand function is q is equal to 100 divided by p minus 1, where q is the quantity demanded and p is the price per unit of good and p is greater than 1. The average variable cost for monopolist is being given by 4 upon under root q and the fixed cost is 10. We need to find out the profit maximizing price. Okay, now what we are being given, we are being given q is equal to 100 upon p minus 1. Let us solve it for first p, that means p minus 1 is equal to 100 upon q, that means p will be equal to 100 upon q plus 1. Okay, this is inverse demand function. Now what is total revenue? Total revenue is equal to price into output. So price function is this 100 upon q plus 1. To this we multiply q, which gives us total revenue is equal to 100 plus q. Okay, and what is marginal revenue? Marginal revenue is simply the derivative of total revenue function with respect to output. Let's denote it by tr prime. Taking derivative of this function, it will give us as 1. Okay, that means derivative of constant is 0 and derivative of q is 1. And what is our total cost? Let's write the total cost function here. So we are being given the average variable cost. Average variable cost is being given as 4 upon under root q. Okay, now if this is average variable cost, then our total variable cost will be equal to avc times q, which gives us avc is 4 under root q. To this, when we multiply q, it will become, okay, it will become 4 under root q. Okay, transposing this, it will get multiplied with this q. So this is our total variable cost. Now total cost is simply equal to total variable cost plus total fixed cost, which is fixed cost. So total variable cost is 4 under root q plus fixed cost is being given us as 10. Okay, and what is marginal cost? Marginal cost is the derivative of total cost function with respect to output. Okay, if I take derivative of this function with respect to output, what will I get? This will become derivative of under root q. So we have q to the power 1 upon 2. Its derivative will be 1 upon 2 q to the power minus 1 upon 2. So it will become 1 upon 2 under root q, and we have 4 also with this. Okay, so we have 4, it will become 2 under root q. Okay, derivative of a constant is 0, so total our marginal cost will be equal to 2 upon under root q. Now profit maximizing condition requires that our marginal revenue should be equal to marginal cost. Okay, if this condition is holding here, then marginal revenue is equal to 1 and marginal cost is 2 under root q, which implies under root q should be equal to 2 or q is equal to 4. That means quantity produced should be equal to 4. And what will be the price then? Put q is equal to 4 in the demand function in this function, so our p will be equal to 100 upon 4 plus 1. That means price would be equal to 26. But I have serious doubt about this method. Okay, why? I will explain it here. So it seems that price should be equal to 26. Okay, but if we look at the demand function, we have q is equal to 100 upon p minus 1. Okay, we know that profit is equal to, okay, profit is simply equal to total revenue minus total cost. Okay, if I plug in place of, we are being told p should be greater than 1, if I put the minimum price here, okay, the minimum price in integer, what will be the minimum price if p is not equal to, if p cannot be equal to 1, then p should be equal to 2. And let us say when we put minimum price here, that means q will, or let's write it here, when p is equal to 2. Okay, that is the minimum thing. When p is equal to 2, what will be quantity? Quantity will be equal to, quantity demanded will be equal to 100 upon 2 minus 1, 2 minus 1, so we get 100. Okay, when p is equal to 2, q is equal to 100. Okay, then profit is simply total revenue minus total cost, so our profit will be equal to total revenue, that is p into q minus total cost. Total cost function we calculated, it came out to be 4 under root q minus 10 when we subtract. So what is p into q means 2 into 100, 2 into 100 minus 4 under root q means under root 100 minus 10. So this gives us 200. So 4 tens are 40, 40 and it is 50. Okay, 4 into 10 is, because under root 100 will become 10, 4 tens are 40 and it is 50, so we subtract 50 here. That means we will get a profit of 200 minus 50, it comes out to be 150 when we plug p is equal to 2. Okay, now let's compare the profit what we got when we use this very stuff. Okay, uh, initially, so initially what price we got when we used this very marginal revenue is equal to marginal cost. So again profit will be total revenue minus total cost, total revenue minus total cost. Total revenue is p, or let's write it here. Okay, so profit will be equal to total revenue, that is p into q minus total cost. For total cost is 4 under root q minus 10. Okay, if we plug, we got price as 26, quantity is 4, minus 4 under root 4 minus 10. So 26 into 4, 4 6 are 24, 4 2s are 8, 9 10, 104 we got here, minus 4 2s are 8, 8, it is 18 here. So here you can see 104 minus 18, it comes out to be, okay, 104 minus 18, what exactly does it come out to be? It will come out to be 86. Okay, so when price was 26, profit for the monopolist is 86, but when we use the minimum price, okay, mm, okay, the profit for the monopolist is 150. Okay, I guess that here the monopolist should charge minimum possible price, and minimum possible price will be 2 here, okay, to maximize his profit, and not using this very condition. And we can see it here also. If I write it here, here we have one thing, our marginal revenue is equal to 1, which is constant, okay, which we got here, 1 is constant. And what is our marginal cost? Marginal cost is equal to 2 under root q, okay. That means here marginal cost will decrease, marginal cost will decrease because we have under root q in the denominator. Okay, so 2 divided by under root q, so it will become this will be less than 1, obviously. Okay, 2 divided by under root anything. So our marginal cost will decrease as our output increases, but our marginal revenue will remain constant. Okay, it will remain constant as output increases. Okay, so our endeavor is to make marginal cost as low as possible. That means the monopolist should produce as much as he can produce. Okay, that means he should produce 100 units here, so that his marginal cost is minimum, since marginal revenue is here constant. Okay, so I don't by this method here, I guess the minimum price that the monopolist should charge should be equal to 2. Okay, so still I'm not sure, but I'm just trying to give another impression here, that is to use the things that are out of box at times. And you can also see, when price is equal to 26, profit is equal to 86. When price is equal to 2, profit is equal to 150. Obviously when price is decreasing, profit is increasing here. Okay, that means the monopolist should charge minimum possible price, that is 2. The question is, a firm in the market with perfect competition has following total cost function, that is TC is equal to A plus BQ, where Q is the quantity produced by the firm, A is the fixed cost, and BQ denotes the variable cost. What will happen if the fixed cost increase in the short run? The options are being given. We need to find out the correct option. The first option is firm's average variable cost will shift upwards. Let us see here. Okay, so we have the total cost is equal to A plus BQ. Let us first see what is the first option. Okay, BQ, this is total cost. Now what is our fixed cost? Fixed cost is our A. Okay, that very cost there does not depend upon the level of output, so this is fixed cost, and this denotes the variable cost, the second term. Firm's average variable cost will shift upwards. Okay, what is average variable cost? Average variable cost will be equal to variable cost divided by output. Variable cost is BQ upon Q, that gives us B. Okay, and here you can see, now if A increases, that is if fixed cost increases, what happens to average variable cost? Since average variable cost is a function of only this B, no A is involved here, that means average variable cost will not change. Okay, average variable cost does not change. It does not depend upon this B here. Okay, so we can say average variable cost will shift upwards. No, this cannot be the correct option. Second option is firm's average total cost will shift upwards. Okay, so what is average total cost? That is simply total cost upon output. Total cost is being given us as A plus BQ. To this we divide by Q. That means our average total cost will be equal to A divided by Q plus BQ divided by Q is B. This is our average total cost. Now here you can see if A increases, okay, this whole term will become big comparatively. If fixed cost increases, this term becomes larger. That means average total cost will also increase. Okay, so if A increases, that is fixed cost, it implies average total cost will also increase. That means it will shift upwards. Okay, so this seems correct option. Firm's average total cost will shift upwards. Okay, third option is the firm will earn higher profit. No, it cannot earn higher profit when its average total cost increases. Firm's last option is firm's marginal cost will shift upwards. Okay, so we know that marginal cost is simply the derivative of total cost function with respect to output. If we take derivative of this function with respect to Q, so in the first term we don't have any Q, its derivative is 0. That means our marginal cost will be equal to derivative of Q is 1, that is equal to B. Here also you can see that marginal cost depends upon this B, which is the variable cost here. Okay, so marginal cost has no relationship with the fixed cost. If fixed cost increases, marginal cost will not change. Okay, not change. So I guess the correct option should be this: firm's average total cost will shift upwards. The question is, suppose the own price elasticity of demand and income elasticity of demand are given by E subscript P and E subscript I, where subscript P and I denote the price and income respectively. Identify the correct statement or statements. Okay, so we are being given four statements. We need to find out which statement is correct. Okay, let's see the first statement. It says, if price elasticity of demand lies between 1 and infinity, the demand is price inelastic. Okay, it is incorrect. Why? When let us say we have quantity on this side, price on this side, when price elasticity of demand is less than infinity and greater than 1, we will have elastic demand curve. Okay, we will have elastic demand curve, and when we have straight line we will have perfectly elastic demand curve. Okay, at that point we will have elasticity of demand is equal to infinity. Okay, so first option is incorrect. Second option tells us luxury goods are more price inelastic and necessities are price elastic. Okay, now it is also incorrect in case of luxury items. Okay, in case of luxury items, income elasticity is always greater than 1, and in case of necessities, income elasticity is less than 1. Okay, so the graph could have been like this. If we have income on this side, quantity on this side, let us say this is our demand function. So it simply says if income increases, okay, let us say if income increases from 1 to 5, quantity demanded will increase from, let us say, 3 to 8. Okay, when income increases, quantity demanded also increases. So for luxury items, income elasticity will be greater than 1. But in case of, necessities, our demand curve will be like this. That means change in income does not change the quantity demanded proportionally. That means if income increases from 10 to, let us say, 13, quantity demanded will change only from, let us say, 5 to, let us say, 5.4. Okay, so there will be minute increase in quantity demanded when income increases more than comparatively. So this is also incorrect. That is, and let me write it here, luxury items are elastic in nature and necessities are inelastic. Third option says luxury goods have income elasticity of demand greater than 1. We have seen it here. Yes, this seems to be correct option. And last option is being told, if price elasticity lies between 0 and 1, the demand is perfectly elastic. This is again incorrect. When income, price elasticity of demand is between 0 and 1, in that case we have relatively inelastic demand curve. So this will look like this. We have quantity, price on this side, so we will have like this kind of demand function. Okay, that means when price increases from, let us say, 10 to 12, quantity demanded will change from, let us say, 5 to 6. There will be, you know less change in quantity demanded compared to change in the price. So I guess and the C option should be correct.
The International Monetary Fund, what we call IMF, began operations in the year. The correct option should be 1947. Operational it became on 1947 and it was founded on 1945. Okay, founded on 1945 and start working or became operational on 1947. Next question is, according to the Working Group on Money Supply Analytics and Methodology of Compilation 1998 constituted by the Reserve Bank of India, which of the following is not component of new monetary aggregate, that is NM1? That means what we also call the narrow money supply. So currency with public, so NM1 includes currency with public plus demand deposits with banks plus other deposits with RBI. So C plus DD plus OD. So this is C, it is correct. Demand deposits with the banking system, it is also correct. Short term time deposits of residents, it is not correct. Other deposits with RBI, this is also correct. Okay, so we are being told to find not a component. That means option C must be correct. Next question is, stagflation is a situation when? So stagflation is a situation of when unemployment is high with the inflation. That means when both unemployment and inflation are high, we have a situation of stagflation. Next question is, an analyst regressed y on x1 and x2. If she later noticed that x1 is equal to 5x2, then which of the following assumptions of classical linear regression model was violated? Okay, so y is being regressed on x1 and x2, and x1 is equal to 5x2. So both are the independent variables. If they are related with each other, that means I guess the correct option should be no perfect multicollinearity. Okay, this violation must have been violated. when the independent variables are correlated with each other. Next question is, among the following, who first proposed that internal government debt does not create a burden for the future generation? The correct option to this question should be option D, that is AP Learner. Next question is, which of the following is an example of direct tax? So by direct tax we mean sales tax, it is the indirect, custom duty, it is also indirect, excise is also indirect. That means individual income tax is the direct tax. Next question is, in Human Development Index, the longevity is measured by, the options are being given here. So life expectancy at birth is, it is the measure of longevity. Child survival rate, it is not. Healthy life expectancy, it has nothing to do with this. Disability adjusted life years, no. So the correct option should be D option. In context of BOP accounting, which of the following transactions is or not recorded under the capital account? Okay, I guess merchandise trade, it is the component of current account, and unilateral transfer payments, this is also the component of current account. Purchase of international financial assets, so it is a sort of investment, it is of the capital account. Purchase of foreign currency by the central bank, so it is a kind of investment, so it is also the part of capital account. So option C and D are the correct options. Next question is, the emission of greenhouse gases is an example of beds that are, the correct option is non-rival and non-excludable.